Hi everyone, in this video I'm going to solve A-Levels Pure Mathematics Paper 2 in a session October-November 2022 Paper 1-2. So let's start with the first question. Question number 1, solve the inequality. So if I open this inequality, we have a plus minus 2x minus 5 is greater than x. So to get rid of this plus minus, let me do scaling on both sides. Right, so we have 2x minus 5 whole square is greater than x square. This is 4x square plus 5 times 5 is 25 minus 2ab. Okay, let me calculate 2ab. So 2 times 2x times 5, which is 20x. So minus 20x and minus x square, this is greater than 0. This is 3x square minus 20x and plus 25, this is greater than 0, right? So this is a quadratic equation in a variable x, and its x square coefficient is positive. So if I draw the parabola, the opening of the parabola is upward, and we have to find the two roots of the parabola, right? And we have to find in which what values of x, or in which inequality the values are greater than 0. So let me solve this. We have 3x square minus 20x plus 25, put it equals to 0, and find the two roots. Let me do the factorization. 3 times 25 is 75, and we have 5 times 15 is 75, and minus 5 minus 15 is minus 20. So 3x square minus 5x minus 15x plus 25, this is equals to 0. Taking x common, we have 3x minus 5. Taking negative of 3 common, negative of 5 is common. 5 times 3 is 15. Yes, 3x minus 5. The two factors are x minus 5 and 3x minus 5. This is equals to 0, and from here x is equals to 5 and x is equals to 5 by 3. Okay, what is 5 by 3? 1.67. Okay, so we have two roots for this parabola, which is 5 and 1.67. Let me draw this parabola with the positive roots. It should be on positive x side, right? And the opening of the parabola is upward because the x square coefficient is positive, and we have to find what values it is greater than 0, right? So as you can see, if I draw this parabola with upward opening, this is 5 by 3 and this is 5, right? Okay, so on what values it is greater than 0? So it is greater than 0 when the values are less than 5 by 3 and more than 5. So when x is less than 5 by 3 and x is greater than 5, the parabola is greater than 0. Question number 2. Use logarithms to solve the equation, giving your answer correct to 3 significant figures, right? So we have to take natural log on both sides, right? So ln of 14 e power minus 2x equals to ln of 5x plus 1. So here we have to do ln of 14 plus ln of e power minus 2x equals to ln of 5 power x plus 1. We have ln of 14 and minus 2x ln of e equals to x plus 1 ln of 5. Ln of e is just 1, so ln of 14 minus 2x equals to x ln of 5 plus ln of 5. Okay, we have to solve for x, so we have to combine the x terms to the left side. So minus 2x and minus x ln of 5. This is equals to ln of 5 minus ln 14. Taking negative x common, we are left with 2 plus ln 5. This is equals to ln 5 minus ln 14. So what is x? X equals to ln of 5 minus ln 14 divides minus of 2 plus ln of 5. Right, let me take the negative sign common from the numerator and cancel it. So we have ln of 14 minus ln 5 divides 2 plus ln 5. Let me solve this and find the value of x up to 3 significant figures. Right, we have ln of 14 minus ln of 5 divides 2 plus ln 5, which is 0.285 up to 3 significant figures. Yes, x would be equals to 0.285. Question number 3, it is given that secant theta is square root of 17, where theta is between 0 to pi by 2. Find the exact value of tan theta plus pi by 4. Okay, so we have identity that is 1 plus tan square theta. This is equals to secant square theta. And from here we have tan square theta. This is equals to secant square theta minus 1. So what is tan square theta? Secant square theta is square root of 17 whole square and minus 1. So tan square theta equals to 17 minus 1, which is equals to 16. And what is tan theta? Tan theta is square root of 16, which is 4. Okay, and we have a plus minus 4. Since the domain is between 0 to pi by 2, the first quadrant, tangent is positive in first quadrant, so we have to pick the positive value, right? Okay, now let me apply the formula tan a plus b, tan theta plus pi by 4, which is equals to tan theta plus tan pi by 4 over 1 minus tan theta into tan pi by 4. Tan 45 is equals to 1. Let me double check. Tan pi by 4 is 1. Yes. Okay, let me substitute the values. So this is tan theta is 4 plus 1 over 1 minus 4 times 1. 4 plus 1 makes 5 over 1 minus 4 is minus 3. 5 over minus 3 or minus 5 by 3. This is the exact value. Question number 4, part A. By sketching a suitable pair of graphs on the same diagram, show that the equation this equals to this has exactly one real root. Okay, so it is easy if I can take natural log on both sides. Yes, and then we can do the sketch. Taking ln e power minus x by 2 equals to ln x power 5. So यहाँ minus x by 2 ln of e 5 ln x. ln of e is just 1, so minus x by 2, this would be equals to 5 ln x. Sorry. Now let us consider y equals to minus x over 2 plus 0. This is in slope intercept form, right? The y-intercept over here is 0 and the slope is rise over run, which is equals to minus 1 by 2. So 1 unit down and 2 units to the right, right? Okay, now for the second graph, let us suppose a second function y equals to 5 ln x, right? So we have to substitute the values starting from the different values of x. So if I can say x and what is y, right? So when x is 0, ln of 0 is infinity, y is infinity. When x is 1, ln of 1 is 0. When x is 2, ln of 2 times 5, 3.5. And when x is 3, ln of 3 times 5, 5.5, and so on. Okay, now let me sketch these two graphs. Let me draw the grid here. Okay, right. Now let me take the scalings for x and y. 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, and minus 3. And same for the y. 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, and minus 5. Right. Let me sketch the graph for the first one. So the line y equals to minus x by 2. The slope, the y-intercept is 0. This is the y-intercept. The slope is minus 1 by 2. 1 unit down, this is minus 1, and 2 units to the right, 1 and 2. So over here, right. Let me draw the scale line. This is a sketch for the first one, right. Now let me sketch the ln function 5 ln of x, right. So when x value is 1, y is 0. When x is 2, y is 3.5. So we have 1, 2, 3, 1, 2, 3, 4, 5. Okay, so in terms of centimeters, okay, when x is 2, y is 3.5. So this is 3 and 3.5 this point. When x value is 3, y is 5.5, more than this. Okay, so this is 3 here. Okay, let me connect the points, and we know that when x is 0, the y value is undefined over here to infinity, right. So let me connect the point to get the sketch. You can say from 1, when x is 2, when x is 3. Okay, for accuracy, let me take the y as 2 units. The scale is 2 units, 2, 4, 6, 8, and 10. Okay, so for 1 it is 0, for 2 it is 3.5, for 2 it is 3.5 between 2 and 4, this point. At 3 we have 5.5, this point. Yes, now we can get the accurate curve, right. Okay, so 1 with 2, 3, and up to so on. And we know that when x is 0, y is downward, it's infinity. So we have to move in the downward direction. This is going to be the sketch for 5 ln x, right. So as you can see that it has exactly one real root. This is the only real root, the point of intersection, right. Now moving to part B, use the iterative formula xn plus 1 equals to this to determine the root correct to 4 significant figures, right. Give the result of each iteration to 6 significant figures. So first we have to find the initial guess, right. So as you can see, we got this equation minus x by 2 equals to 5 ln of x, right. So from here we can say that minus x or x would be equals to minus 10 ln of x, right. Okay, now let me find the root. So as you can see that the initial guess, the root lies between 0 and minus 1, right. So let me check at 0, right. 0, and over here ln of 0 is infinity, right. So we can say 0 is less than infinity, right. Okay, we are checking at x value. So as you can see, the root lies between 0 and 1, right. So when we put x equals to 0, ln of 0 is infinity, right. So 0 is less than infinity. When we put 1, ln of 1 is 0, so ln of 1 is 0. 0 times minus 10 is 0. So 1 is greater than 0. So it means the root lies between 0 and 1, right. So we can take an initial guess. Let the initial guess be, we can take x naught between 0 and 1, we can take 0.5, right? Okay, now let me make a table for xn and xn plus 1, right? Starting point from xn, when we have xn is equals to, we have xn x0, which is 0.5. We put 0.5. What is xn plus 1? Let me calculate this. We have to do the cube root, the fifth root of e power minus x is 0.5, 1 over 0. It's minus x by 2, minus, yes, 0.5 by 2, which is 0.9. We have to find the result of each iteration up to 6 significant figures. Yes, 0.95, 1, 2, 1, 2, 3, 4, 5, 6, 2, 9. Okay, 0.951229. Let me substitute this value here. The answer, we have 0.909 and 261, right? And then substituting the answer, 0.909261, we have 0.913085. And for the next one, we have 0.912736. And for the next iteration, we have 0.912765. Yes, right. The next is 6, 5, and then answer, this is 0.912765 again, up to so on. So we have up to 4 significant figures. We have 0.9, 9 is constant, and then we have 1, and then we have 2, and then we have 7 rounded to 8. Yes, so we can say that the root is 0.9128, up to 4 significant figures. Question number 5, a curve has equation we have given. Find the gradient of the curve at the point 0, -7, right? So let me differentiate this. We have to use a product rule. The first function stays the same. The derivative of the second function, d by dx of y, plus the second function stays the same. The derivative of the first function, e power 2x, plus the derivative d by dx of y square equals to the derivative of 21 with respect to x. So we have 4. This is e power 2x dy over dx plus 4y, and this is e power 2x, and the derivative of 2x is just 2, plus 2y, and the derivative of y is dy over dx. This is equals to 0. Constant derivative is 0. 4 e power 2x dy over dx, 8y e power 2x plus 2y dy over dx. This is equals to 0, right? Now let me take dy by dx common. We have 4 e power 2x plus 2y. This is equals to minus 8y e power 2x, right? Okay, let me find dy by dx. which is minus 8y e power 2x over 4 e power 2x plus 2y. Okay, so this is the gradient of the curve. We need to find the gradient at a point 0, 7, when x is 0 and the y is 7. So we have dy over dx minus 8 times minus 7 e power 0 over 4 e power 0 plus 2 times of minus 7. Y is negative 7 and the x is 0, right? Now we have minus 8 times minus 7, which is positive 56. E power 0 is 1. 4 e power 0 is 1 and 2 times 7 is 14, minus 14. So 4 minus 14 is minus 10. 56 over minus 10, right? 56 divides negative 10, which is minus 28 over 5. So the gradient of the curve at a point 0, minus 7 is minus 28 over 5. Question number 6, a polynomial p of x is defined by, this is a polynomial, part A, find the quotient when p of x is divided by 4x minus 3 and show that the remainder is equals to 2. So let me use a long division method here. It is divided by 4x minus 3. We have a polynomial 12x cube minus 9x square plus 8x and minus 4. Okay, so 4x, 4 times 3 is 12, x square. So this is 12x cube. Okay, 3 times 3 is minus 9, x square, right? Let me subtract this. By changing the signs, we can, this is cancel and this is cancel with a positive negative. Let me take 8x minus 4 down. 4 times 2 is 8 plus 2. 4 times 2 is 8x and minus 6. Again change the signs and we can see that positive 8 and negative 8x is cancel out and 6 minus 4, which is equals to 2. This implies remainder is equals to 2. This is a remainder and the quotient is 3x square plus 2. This is a quotient and remainder. Now for part B, hence find the integration of polynomial over 4x minus 3 minus 3x square dx, giving your answer in the form of a plus ln b, right? Okay, we have 12. The polynomial is 12x cube minus 9x square plus 8x minus 4 divides 4x minus 3 minus 3x square with respect to dx, right? Okay, so when polynomial is divided by 4x minus 3, so we have given that the polynomial is divided by 4x minus 3, we can write this as 2 to 12. First we need to write down the quotient 3x square plus 2 plus remainder over the divisor, and this minus 3x square is as it is dx, right? So here we can do plus 3x square minus 3x square is cancel out, so the only simplified integration is 2 over 12. We have 2 plus 2 over 4x minus 3 with respect to dx. Now let me integrate this function. So 2 is outside, integration 2 to 12, 1 dx plus 2 is outside, integration of 2 to 12. The derivative should be complete, so 4 is multiplying and dividing over 4x minus 3 dx. The derivative of 4x minus 3 is 4, which is complete in the numerator. Okay, so we have 2, this is x from 2 to 12 plus 1 by 2 ln of 4x minus 3 from 2 to 12. right? So we have 2x plus 1 by 2 ln of 4x minus 3. The limits are from 2 to 12. Let me substitute the limits. The upper limit is 12, 2 times of 12 plus 1 by 2 ln of 4 times 12 minus 3. This is the upper limit, minus the lower limit is 2. So 2 times of 2 plus 1 by 2 ln of 4 times 2 minus 3. Right. Now 2 times of 12 is 24. And this is 4 times 12 minus 3 ln of 45 over 12. Minus 2 times 2 is 4 and minus 1 by 2 ln of 4 times 2 8 minus 3, which is 5 ln 5. Okay, now 24 minus 4, this makes me 24 minus 4 plus 1 by 2 ln of 45 minus 1 by 2 ln of 5. So this is 20. Okay, now let me take 1 by 2 common. We are left with ln of 45 minus ln of 5. Right. Further simplification, we have 20 plus 1 by 2 ln of 45 over 5. So this is 20 plus 1 by 2 ln of 5 times 9 is 45. And we can do 20 plus ln of 9 power is 1 by 2. So square root of 9 is 3. 20 plus ln of 3. So the integral is in the form of a plus ln b. A is 20 and b is 3. Question number 7. The diagram shows the curve with equation this. This is a curve. The curve crossed the x-axis at point A. So it means the y-coordinate of the curve equals to 0. At point A, the y-coordinate is 0. We have some x and the y is 0. Right? And has a maximum point at B. So B is the maximum point of the curve. The shaded region is bounded by the curve and the lines x equals to 3 and y equals to 0. Part A, find the gradient of the curve at point A. So first we need to find the coordinates of point A. Coordinates of A. X and the y coordinate is 0 because it is on x-axis, right? So when the y coordinate is 0 in the curve, we have 0 ln of x over 3x plus 1. We have to do the cross multiplication here. So we can do ln of x would be equals to 0, or we can say ln of x equals to 0. So ln of x equals to 0 at x is equals to 1. Right. So the x coordinate is 1 and the y coordinate is 0. A is 1, 0. Right. Now let me find the gradient of the curve. So gradient of the curve is dy over dx. Okay. So here we have to use the quotient rule, right? So the denominator term square function is square. The denominator function 3x plus 1 and the derivative of the numerator function. So we have 2 times ln of x derivative is 1 over x minus the numerator function, and the derivative of denominator function is just 3. Right. Further simplification, we have 2 over x into 3x plus 1 minus 6 ln x over 3x plus 1 whole square. So this is a gradient of the curve. Now let me find the gradient at point A. Okay, so we can say that at point A, which is 1, 0, x is 1, y 0. So we can say that dy by dx at x is equals to 1. So we have 2, 3 plus 1 minus 6 ln 1 and divides 3 plus 1 whole square. And then of 1 is 0. So 3 plus 1 is 4 and 4 times 2 makes 8. 8 over 3 plus 1 is 4, and 4 square is 16. So this is 8 times 1 is 8, 8 times 2 is 16. So 1 by 2. Now for part B, show by calculation that the x-coordinate of B lies between 3.0 and 3.1. Okay, so as we know that B, the maximum point of the curve is point B, and to get the maximum point we have to find the first derivative equals to 0, right? For maximum point, what we have to do, we need to put y prime equals to 0. So we have the derivative which is equals to 2 over x into 3x plus 1 minus 6 ln x divides 3x plus 1 whole square, put it equals to 0, right? So we have to solve for x, right? So we have to do the cross multiplication. So here 2 over x, 3x plus 1 minus 6 ln x, this would be equals to 0, right? Okay, let me multiply all the terms of both sides by x by 2. X by 2, right? So we are left with 2, no, over here we are left with 3x plus 1 minus 6 ln x times x by 2 equals to 0, right? So we have 2 times 1 is 2, 2 times 3 is 6, so we have 3x plus 1 minus 3x ln x equals to 0, right? Now further simplification, let me take 3x common. We have 1 minus ln x, this is equals to negative 1, and we can say 3x equals to 1 over ln x minus 1. And what is x? X would be equals to 1 over 3 into ln x minus 1, right? So we have to show by calculation that the x coordinate of B lies between 3.0 and 3.1. So we have to check at 3.0. At x is equals to 3.0. So this x is 3.0. And what is this calculation? 1 over 3 ln of 3.0 minus 1. Let me calculate this. Ln of 3 minus 1 times by 3 and its reciprocal, 3.4. This is equals to 3.4. So we can say that 3.0 is less than 3.4 here, right? Now let me check at the next one. At x is equals to 3.1. Okay, so just substitute this x 3.1, and this would be equals to 1 over 3 ln of 3.1 minus 1. Okay, so we can say ln of 3.1 minus 1 times 3, 1 over answer 2.5. This is 2.5. So here we can say that 3.1 is greater than 2.5. Okay, so means the function changes the sign. This means because of sign change, x coordinate of B lies between 3.0 and 3.1. So that is a reason. Now for part C, use the trapezium rule with the two intervals and values to find an approximation to the area of the shaded region. Give your answer correct to do decimal place. Okay, so the trapezium rule, we have to find the area. The formula is 1 by 2 into b minus a over n, right? And function value, okay, so as you can see between they said area of the shaded region only. This is a shaded region, so x is 1 and x is 3, between 1 and 3, right? So the a and b values are 1 and 3. right? So we have to do 1 and 3. So function value at 1 plus 2 times function value at 2 plus function value at 3, between 1 and 3, right? Now let me calculate this. 1 by 2, b value is 3 minus a value is 1, because we are doing between 1 and 3, over the number of intervals are 2, function value at 1, y value at 1. So what is 1? We have ln of 1 is 0, so this is just 0, plus 2 times we have ln of 2, 2 ln 2 over, we have 3 times 2 plus 1, plus 2 ln 3 over 3 times 3 plus 1. Okay, now let me calculate this. So 3 minus 1 is 2, 2 by 2 is just 1, so we are left with 1 by 2 here. Okay, so 4 ln of 2 over 3 times 2 is 6, 6 plus 1 is 7, plus 2 ln 3, 3 times 3 is 9, and 9 plus 1 is 10. Okay, we need to find the answer up to 2 decimal place, right? Let me calculate this. Okay, let me calculate this. We have 4 ln 2 divided by 7 plus 2 ln 3, and we have divided by 10 and divided by 2. This is 0.307, and up to 2 decimal place the answer is 0.31. So we can say the area is 0.31 up to 2 decimal place. Question number 8, the expression f of theta is defined by, this is the expression for f of theta. Part A, express f of theta in the form of r cos 2 alpha 2 theta minus alpha plus k, where r is positive and alpha is between 0 and pi by 2 and k is a constant. State the value of r and k and give the value of alpha correct to 4 significant figures, right? Okay, first we have to convert this into this form. Okay, what is f of theta? So we can say that f of theta, let me simplify by making the double angle formulas. We can do 6 times 2 is 12 sine theta cos theta, right, plus 16, or we can say 8 times 2 is 16 cos square theta, and minus 1 and plus 1. Okay, so 2 cos square theta minus 1 is cos 2 theta, and this would be equals to r cos 2 theta minus alpha. 6, this is sine 2 theta, plus 8, this is 2 cos square theta minus 1, and plus 8 times 1 is 8, this is equals to r cos 2 theta minus alpha plus k as well. I forgot to put plus k. This is 6 sine 2 theta plus 8, this is cos 2 theta plus 8, this is equals to r, opening the formula here, which is cos 2 theta minus alpha. The formula is cos 2 theta cos alpha plus sine 2 theta sine alpha, and plus k, right? Now let me do the comparison. We can say comparing coefficients of the first, let me compare the coefficient of cos 2 theta. Okay, so here cos 2 theta is 8, and on the other side cos 2 theta is r cos alpha. Okay, the next, comparing coefficient of sine 2 theta. Here we have 6, and here we have r sine alpha, and the constant k value is 8. If we compare the constants, we got the k value which is equals to 8. So we have done with the k value. Now let me find r and alpha, right? Okay, this is my first equation and this is my second equation. Let me do scaling and adding of two equations. R square sine square alpha plus r square cos square alpha. This is equals to 6 square plus 8 square, right? For the simplification, we have r square sine square alpha plus cos square alpha. This is 1, right? 6 square is 36, 8 square is 64, right? So what is r square, which is equals to 36 plus 64 is 100, I guess. 64 plus 36, yes, this is 100. And the r value is plus minus 10, but we have to take the positive one because r is greater than 0. So r is 10 and k is 8. Now let me solve for alpha. And alpha value should lies between 0 to pi by 2 in the first quadrant. So we can solve for alpha by doing r sine alpha, dividing second equation over first equation over r cos alpha, which is 6 by 8. Right. So r is cancelled with r. So sine alpha over cos alpha is tan alpha, which is 2 times 3 is 6 and 2 times 4 is 8. And alpha is tangent inverse of 3 by 4 just in the first quadrant and in terms of radians, right? Tangent inverse of 3 by 4, which is 0.6435 up to 4 significant figures. We have to find the answer for alpha. So alpha is 0.6435. This is up to 4 significant figures. Now we can express f of theta in the form r cos 2 theta minus alpha plus k. Okay, so let me rewrite. So r value is 10 cos 2 theta minus alpha is 0.6435 plus the k value is 8, right? Now for part B, find the smallest positive value of theta satisfying the equation f of theta should be equals to 17. So we have f of theta which is equals to r 10 cos 2 theta minus alpha 0.6435 plus the k value 8. This is equals to 17. We have to solve for theta. Okay, so 10 cos 2 theta minus 0.6435. This is equals to 17 minus 8, right? So we can say cos of 2 theta minus 0.6435. 17 take away 8 is 9. 9 by 10 divided by 10 is 0.9, right? So from here we can say cos of 2 theta minus 0.6435 equals to 0.9. We have to find the smallest positive value of theta, right? Now let me do cos inverse. So from here 2 theta minus 0.6435, this is cos inverse of 0.9. Let me calculate cos inverse 0.9, which is equals to 0.4510. Okay, now let me suppose that this value, this whole thing is equals to phi. So we can say phi is equals to 0.4510. Now this is cos is positive in first and the fourth quadrant. So for fourth quadrant we have to do 2 pi minus theta. So 2 pi minus 0.4510, which is 5.8322. So the phi value for the fourth quadrant is 5.8322, right? So since there are two revolutions, so we have to add and subtract 2 pi. So phi plus 2 pi and phi minus 2 pi. Okay, so in these values we are adding. So phi is 0.4510. We add 2 pi which is equals to 6.7342. And for the second one, let me subtract 2 pi, which is minus 5.8322. Right, now the same for the other number. Let me add first 5.8322, add 2 pi is 12.1154, and same number subtracting 2 pi is minus 0.451. Okay, now let me solve for theta. So we have the phi value. So for theta value, we can say if 2 theta minus 0.6435 is equals to phi, so what is the theta value? So theta is equals to phi plus 0.6435 and divided by 2. Right, so we'll get theta. So let me find all the values of theta. Now you can see we have 1, 2, 3, 4, 5, 6, 6 values of theta. So we need to check which one is the smallest. Okay, so starting from the first one, we have phi 0.4510. We add 0.6435. Right, and we divide it by 2. Divided by 2, 0.54725. Let me write down all the values and pick the smallest one. 0.5472. Let me check for the second one. We have 5.8322. This is 3.2378. 3.2378. For this one, 6.7342. This is 3.688. For the next 12.1154. This is 6.379. And then minus of this, minus 5.8322, which is negative of 2.594. And the next one, the last one, is minus 0.451, which is equals to 0.09625. Okay, so which one is the smallest one? We need to pick the smallest and the positive. So this is cancelled because this is a negative one. So we need to pick the smallest and the positive. 0.5, 3.2, 3.8, 6.3, 0.0. So that we can say that smallest positive value of theta is 0.0962. Now for part C, find integration of f of theta d theta. So let me write down integration. F of theta is basically 10. We have cos 2 theta minus 0.66435 and plus 8. This is f of theta. With respect to d theta, the integration is 10. The integration of cos is sine with respect to theta, and the derivative of this angle is 2, so divided by 2 plus 8 theta. Right, so this is 5 here, so we have 5 times sine 2 theta minus 0.6435 plus 8 theta. This is also correct, or you can open this formula. So we have 5 sine 2 theta cos 0.6435 and minus cos 2 theta and sine 0.6435 plus 8 theta, right? Okay, now let me calculate what is cos 0.6435 is this, and times by 5, which is 4 of sine 2 theta. So 4 sine 2 theta, and finding with sine 0.6435 is this, times with minus 1 and times by 5, which is negative of 3, we can say if we round it. So negative 3 cos 2 theta plus 8 theta. Okay, so this is the answer for the integration. So that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.